show that if the diagonals of a quadrilateral bisect each other at right angle, then it's a rhombus. So I will draw the diagram for you guys. And as usual, you guys have to write the description of the diagram and what is that we need to prove. So we are looking at ABCD or rhombus. It doesn't look like a rhombus though. 1, 2, 3, 4. Yes, I should get it till here. Better. So this is a rhombus, supposed to be a rhombus. Okay, you guys have to recall what is a rhombus, what is that we need to prove and all of that, and how to prove it. So property of rhombus is something that you guys have to think over. So the diagonals, they intersect and make an angle of 90 degree. Now describe the diagram, try to figure out what is given and what is that we need to prove. So we have been given that. Let's consider ABCD a quadrilateral where diagonals bisect each other at right angle, where AD and where diagonals AD and not AD, sorry, AC and BD bisect each other at 90 degree. Okay, so what can we tell? We can tell quite a few things. That is, let AO AC be equal to 2x and DB equal to 2y. Then we can tell, then we have AO which is equal to OC which is equal to AC by 2 which is equal to x, and we have TO is equal to OB which is DB by 2 which is equal to y, right? So each of this is equal in this way, and then we also can write angle AOB, all of this are equal to 90 degree. Actually there are quite a few things, we'll write it when we need it. Okay, so what is the next thing? What else? So I think we just have to write to prove ABCD is a rhombus. So how do you prove ABCD is a rhombus was my question. I hope you guys are able to figure it out. So indirectly we have to prove that all, yes, sides are correct. Any idea? Equal. If I prove that all the sides are equal, then we are done. So how do you prove that all the sides are equal? That's the question. We have to make use of congruency. Okay, it's quite simple. It's very clear from the diagram. Proof in triangle OAD and triangle OBC. So we have OA is equal to OC which is equal to x, OD which is equal to OB which is equal to y, and angle DOA is equal to angle COB. All of this are equal to 90 degree, if not vertically opposite angle. Okay, so with all of this in mind, we can tell triangle OAD is congruent to triangle OAD OCB by SAS congruency. And so we can tell AD is equal to CB. Thus, AD is equal to CB by CP CT. So we proved these two sides are equal. Then we can tell similarly we can prove triangle ODC is congruent to triangle OAB, right? So remember, we proved that these two triangles are congruent. Now I'm talking about these two triangles, right? They too have to be congruent. Okay, so similarly we can prove that this implies DC is equal to AB. So we'll call this as 1 and 2. I think we'll be using that. Now, we proved that opposite sides are equal, but we have to prove all the sides are equal. So to do that, we need to consider, say, 1 and 2, these two triangles, and prove that they are congruent. That's it. Okay. So let's consider triangle OAB and triangle let's see, OAB and OCD. Okay, OCD. Any adjacent triangles, if you prove, that's enough. So here we have OB common, then BOA is equal to BOC, BOA, angle BOA is equal to angle BOC, which is equal to 90°, and we have OA is equal to OC, and we have OA is equal to OC, which is equal to X, right? And so by SAS congruency, triangle OAB is equal to is congruent to triangle OCD. So with this we can tell AB is equal to CD, right? OAB is equal to OC. Okay, sorry, OCB or OCD. Oh, I wrote it wrong. This is that is correct. Here. Yeah, now it's correct. OCB. And this too is CB. So AB is equal to CB, and pretty much all the sides are equal to each other. So from 1, 2 and 3 we can conclude all the sides are equal. Thus from 1, 2 and 3 you can conclude all sides are equal. Thus ABCD is a rhombus, right? And that's your answer.